What is going on, guys? Welcome back. In this video today, we're going to do a full SQL Alchemy crash course for beginners. Now, SQL Alchemy is a database toolkit for Python as well as an object relational mapper. We're going to discuss these two terms in a second here. And it's one of the most essential Python packages when it comes to working with databases or integrating databases into your applications. It's frequently used in Flask and Fast API and sometimes also in Django to replace the default Django ORM. What it allows us to do is to work with databases without having to write any SQL code directly. We can use Python functions, we can define Python classes instead of tables, and all of this is handled by SQL Alchemy for us. We can just stay in the Python world, so to say, and interact with the database. So we're going to learn a lot in this video. We're also going to look at some use case examples in the end. If you like these kinds of tutorials, let me know by hitting a like button and subscribing to this channel. But now let us get right into it. Now, before we get into the actual tutorial, I would like to mention that this video is sponsored by Snyk, a company focusing on AI security. And I do recommend that you don't skip this section because it's going to be quite relevant to a lot of you guys, since my audience is mainly focused on coding and AI, and I assume most of you guys are using LLMs in some way or another for coding. Now, what Snyk has coming up is a live workshop focusing on the exploitation of AI-generated code. It's happening on April 3rd, 2025 from 11 a.m. to 12:30 p.m. Eastern Time. And what you're going to learn in this workshop is how insecure most of the AI-generated code is, how to spot these vulnerabilities, how to spot these security risks, and most importantly, how to mitigate and fix these vulnerabilities, so how to write secure code and how to not fall into the traps of AI-generated code with the security issues. What you're going to do in this workshop is you're going to use GitHub Copilot to build a demo application, and you're going to uncover the vulnerabilities that were generated by the AI, and you're going to learn how to fix them. So if you are somebody who develops applications using AI, especially applications where security is something of interest, you should definitely attend this workshop to improve your skills and also to raise the awareness when it comes to vulnerabilities in AI-generated code. The only thing that you need to participate is a ChatGPT account, a GitHub Copilot account, a free Snyk account so you don't have to pay anything for that, and an IDE like VS Code or JetBrains, for example. You can get to this page by clicking at the link in the description down below. All right, so we're going to learn SQL Alchemy in this crash course today. Now, SQL Alchemy is split into two parts. The package consists of two parts. One is SQL Alchemy Core, which is the database toolkit for Python, and the other part is SQL Alchemy ORM, so the Object Relational Mapper, where we can define database tables as Python classes, and we can use the object-oriented programming paradigm to work with our database, to interact with our database. We can treat individual rows as objects, we can treat tables as classes, and the ORM part is built on top of the SQL Alchemy core part, so it's based on that. Now, what I want to do in this course is I want to start with the very basics of SQL Alchemy. I want to show you how you can execute raw SQL code in the database by using SQL Alchemy. Then I want to cover the basics of SQL Alchemy Core, and then I want to move to the most interesting part, in my opinion, which is SQL Alchemy ORM, because that is what we usually use when we define database models in our backend applications, so in our backend APIs, for example. So when we use Flask or Fast API or Django, as I said, sometimes to replace the Django ORM. And in the end, I also want to show you a practical example of an old application, of an old Flask application where I use SQL Alchemy for the database model and for the database interaction. And I also want to show you a Pandas example because we can use SQL Alchemy in combination with Pandas to apply certain data frame operations to the database by using SQL Alchemy. So we're going to cover quite a bit in this video today. Let us get started by installing SQL Alchemy onto our system. For this, we're going to open up a command line and we're going to type pip or pip3 install SQL Alchemy. Now, what's important here is if you already have a version of SQL Alchemy on your system, make sure it's a version that starts with 2, so 2 point something. You can make sure that that's the case by opening up an interactive Python shell and typing import SQL Alchemy. And then you can say SQL Alchemy dot _ version _ If that version is 2 point something, it's fine. If it's 1 point something, you want to consider updating your version by saying pip or pip3 install -U and then SQL Alchemy. This is going to install the latest version. And the reason for that is that a major version is oftentimes quite different than the previous major version. So 2 point something is going to be quite different and partly incompatible with 1 point something. I'm not sure if this is going to matter for this tutorial today, but if you want to make sure that you use the same version that this tutorial is based on, go and install SQLAlchemy 2 point something. Now, what I want to get started with here first is I want to show you how to run very basic SQL commands, raw SQL commands in the database using SQLAlchemy. For this, I'm going to open up a Python file. Let's call it basics.py. And what we're going to do here is we're going to say from SQLAlchemy import create engine. Now, create engine is what we're going to use to create an engine, and this engine is going to be what we use to connect to a database. So we're going to say engine is equal to create engine, and then we need a so-called connection string. So we need a database URL. Now, the most simple way to work with a database is to just use an in-memory database or a file-based database. So we can use SQLite, and we can just work with a database that is stored in a file or even in RAM. But the cool thing about SQLAlchemy is that you don't really have to care about the underlying database. You can use Postgres, you can use SQLite, you can use MySQL. It doesn't really matter because you just have to write Python code, and then SQLAlchemy is going to run the corresponding or the respective code on the database with the respective dialect, with the respective language features. It's going to adjust it automatically behind the scenes. You don't have to do it yourself. Now, that's of course not true if you write the SQL code yourself, which is what we're going to do here now. But let us get started by just typing SQLite and then : / so 3 slashes, and then just a file name, for example, mydatabase.db. And what we also want to set here for debugging or for learning purposes is we're going to say echo equals true. We want to see what is happening exactly when we're running commands. So I'm going to create this engine like that. And then what we do is we connect to the database through this engine. So we say connection is equal to engine.connect. So now this con object is a connection object that we can use to execute commands. So I can go ahead and say con.execute. And I can pass something like create table if not exists. By the way, I'm not going to teach SQL code in this video today. I do have a SQL crash course where you can learn about the syntax of creating a table, inserting data into a table, and so on. I'm going to assume for this tutorial that you either already know SQL or that you don't have any interest in learning about it. So you just want to use SQLAlchemy in a programmatic way in Python. You don't really care about SQL. You don't really care about what is happening behind the scenes, or you already know about it. I'm not going to teach it here. So create table if not exists. Let's call the table people. Let's say I want to have a name, which is a string, and I want to have an age, which is an integer. And that's basically it. I can do it like that. And actually, one thing that we need to do here is we cannot just pass this raw text here, but we need to wrap it into a function which is text. So we need to say from SQLAlchemy import create engine and also import text. And then we're going to just call text onto this statement. And in order to actually make the change in the database, so this is going to execute the statement, but in order to actually apply the changes to the database, we need to also say connection commit to persist the changes. So I can run this now, and you can see what happens here is begin, create table if not exists people, and then generate it and then commit. What we can do now is we can go out of this and I can just say SQLite 3. Now actually I need to see if the database is here. It is. So SQLite 3 mydatabase.db, and now I can say dot tables, and I can see we have the people table here. I can also say pragma table underscore info people, and actually I need a semicolon here, and you can see I have name, string, and age integer. So that works. Let us go back into our code. What we can also do is we can work with sessions, and sessions are going to be important when we go to the ORM, because the basic rule here is when you work with SQLAlchemy core, you work with connections. When you work with the ORM, you work with sessions because they do some additional stuff behind the scenes. But let's just see what this looks like. We can say from SQLAlchemy.orm import session. And if we are using SQLAlchemy core, but still working with a session, basically it's the same as working with a connection. So I can say session is equal to session based on the engine. This is going to start a session with the respective database. And then I can just say session execute, and I can do something like text and then insert into people, name age, values, and then maybe I should use single quotations here, just because I like to use double quotations in the SQL strings or in the SQL commands. So let's go with Mike and then 30 semicolon, and then just do session.commit. When I run that, you can see this is also executed. I can close this, I can go to the database again, and I can say select everything from people, of course, without the single quotation. So again, now correctly select from people, and you can see we have Mike and 30 here. So let's go back into our code. This is the most basic way to work with SQLAlchemy. This is not really what you do with SQLAlchemy. That is just running SQL code directly. That is not what you use the package for. What you use it for is to work with either SQLAlchemy core, where you can use functions and you can use metadata to create everything in the database easily, or you use an ORM, the Object Relational Mapper, to map Python classes to database tables. We're going to take a look at that later on in the video. So what I want to show you now is how we can do that, or how we can work with SQLAlchemy core first, just so you know what it's about, and then we're going to get to the most interesting part, which in my opinion is the ORM. But now let us take a look at SQLAlchemy core. For this, we're going to start by removing the text import. We're no longer going to write raw SQL code, and we're going to have to import a couple of classes here. The most important one being the metadata class, because that is going to be an object that keeps track of all the information. It's like a facade for a dictionary behind the scenes. It's going to keep track of the information necessary to create tables, columns, constraints, and so on. And when we work with SQLAlchemy core, we have to work with a metadata object. When we work with SQLAlchemy ORM, we work with a declarative base, which we're going to take a look at later on, as I said. But we're going to have to import now metadata. Also, we want to import table, and we want to import column. All of these are classes. You can see capital M, D, T, and C. And we're going to start by creating here a meta object. So meta being equal to metadata. And in order to define a table now, what we do is we just say people, for example, is equal to table. So we create a table object, and this table object now takes a couple of parameters. The first one being the name of the table, so obviously people. The second one is the metadata object, so in this case meta. And then what we do is we pass the columns. So for example, I can say the first column here is an ID, and the ID is of type, and for this I need additional imports here. Integer and string are two imports I'm going to use here. So these are just data types. So I can say the ID is an integer column, and it's also the primary key. So I set the keyword argument primary key equal to true. And then I say column name, for example, is a string. Now, if I want this to be a required field, so if I don't want to allow for any null values, I would say nullable equals false. This would make this a required field, so everybody has to have a name. You cannot just have an empty value here. And then let's say I want to also have a column age, which is an integer. So that would be the definition of a table. Now, in order to create a table in the database, what I have to do is I have to do meta.createAll, and I have to pass the engine. So the metadata that I have based on these tables, in this case now I only have one table with 3 columns, this is all kept track of here in the metadata object by passing it here as a parameter. And in the end, I just say create all, and this is going to do the respective necessary actions in the database. So we can give that a try. I can just go ahead. Now, first of all, what I want to do is I want to remove the database. So I'm going to say, what was it called? My database DB. Let's go back into the code. Let's run this. And what you can see now is that this was executed, create table people, ID integer not null, name varchar not null, age integer, and then primary key ID. This is the translated SQL code, or this is the SQL code that was generated based on the Python code by the metadata object. And if I now go into the database, if I open it up again with SQLite 3, and if I say .tables, I can see people, and if I say pragma table info and people, we're going to see ID name H. So that's perfect. Now, one cool thing, this is like a key feature of SQLAlchemy I already mentioned before, is that we can just switch to a different database. We don't have to change anything about the code, and it's still going to work. We just have to change the connection string here, or the database URL. So I can copy that, I can comment that out, and I can now say, for example, I want to use Postgres. Now, in this case, I already have Postgres set up on my system. I'm not going to show you how to do that, but I want to use Postgres with a dialect of Psycho PG2. And of course, in this case, I have to provide a different connection string because Postgres is not a file-based database. So I have to say username, which is Postgres, password, which is Postgres, and then at localhost port 5432, and then slash whatever I want to call the database. Let's call it SA tutorial for SQLAlchemy tutorial database. Let's just save that. Now what I need to do, of course, is I need to say create DB SA tutorial database. But then I can just go into my code. I can run this. You can see everything was executed here. Now, since this is a different type of database, now I have here serial and not integer, because that's in Postgres what we use for an ID. And yeah, the rest I think is the same. But now I can do the same thing. I can just connect PSQL dash u Postgres dash dash DB name and then SA tutorial database. Then I can provide the password Postgres, and then I can just say backslash DT. I can see the table here. I can say D people, and you can see we have ID, name, H, everything applied here. That's cool about, or that's the magic of SQLAlchemy. You can keep the Python code the same because that's your level of abstraction, and everything is handled behind the scenes by the engine and by the metadata. Now, we cannot just create these tables, we can also work with them, and for that, again, we need a connection object. So I need to say connection is equal to engine.connect, same as before. But now what we're going to do is we're not just going to run raw SQL code, we're going to use functions. And what we can do here is we can either use the people table, or we can use specific functions that we can import from SQLAlchemy. So one way, for example, to insert data would be to say, I want to have an insert statement. This insert statement is equal to people, which is my table, and then people.insert. So I call insert, and then based on that, I also call values. So it's a chain of function calls. Here, people insert values. Now, people is not a function, but insert is a function, values is a function. And here now I can pass, for example, name equals Mike, and age is equal to 30, for example. Now, this gives me an insert statement. If I want to execute it, what I can do is I can say result is equal to connection execute this insert statement. Now I don't need the result if I don't want that, but insert statement is going to be passed here. Statement, of course. And then I can just say connection commit. So I can run this. In this case, it runs, where is it? Insert into people, name, age, values, name, age, and then it returns a people ID if I need that for some reason. And we can go now back into the database. I can say select everything from people, of course, with a semicolon again. So let me run this again. Select everything from people. And then I get Mike and 30 with ID 1. So you can see this is how this is done. And we can also do that in a different way. It depends on what you prefer. You can also import an insert method here, or an insert function, and then you can do the same thing, but you can say insert and then people. That is also equivalent. So here, let's go and say Jane is 40. Let's run this. That is going to do the exact same thing. I'm not going to go into the database now, but that is also equivalent. And you can do that with all the different functions that we're going to call now. You can do that with select. You can do that with update, delete. But I just don't want to import so much stuff, so I'm going to keep it like this, people insert. I'm going to get rid of this, though, because we don't want to always insert the same entry over and over again. So I'm going to remove that. And now we're going to see how I can select data. So for this, I would create a select statement, and I would say people.select. This is a function again, and then I can call the where function. And in the where function here, I can specify people.c.age, for example, is greater than, let's say, 30. So in this case, I should only get Jane because Mike is exactly 30 years old. And then I can say result is equal to connection, execute, select statement. Now, did I import something? Yeah, actually, I didn't want to import that. So let's do it like this, select statement. And now in order to get the results, I would have to fetch the result. So I would do something like for row in result, because this could return multiple rows. For each row, I want to, or actually result dot fetch all. So this is going to give me all the results. Fetch one would give me the first one. So for row in result dot fetch all, I can just print the row. So if I run this, you can see I get 2 Jane 40. Now, if I have a different query, if I say greater than 20, for example, that is going to give me Mike and Jane. So that's a simple select statement with a filter. Of course, if you don't provide a filter, you're just going to get everything. That's also a possibility here. No problem with that. That is a simple select statement. Now, updating is also quite straightforward. Let's say I want to change the age of Mike. What I would do is I would say people update. Then I would say where, and then I would say people.c.name is equal to Mike, for example. That is the condition. And then I want to update. I can say, dot values, and I can say age is equal to 50, for example. And that, of course, is not a select statement, but an update statement. And we also want to execute that statement. And that is going to do the following. Update people set age is equal to placeholder. So we have a prepared statement here where people name is equal to whatever the name was, in this case, Mike. And if we now do a select statement again, which we can do by just reversing everything here, we should see that Mike has an age of, actually, no, I made a mistake. We need, of course, to commit the change. So connection commit is important, otherwise it's not applied to the database. So I can close this again, and now we can go back to the select statement. And now when I run this, you can see Mike is 50 years old. Perfect. And of course, we can do the same with the delete statement. I can just go ahead and say delete statement is equal to people.delete. Now, of course, I need, again, a condition where people.c.name is equal to Mike, for example. We want to make a deletion. Here we're going to say delete statement. And we want to do connection.commit. I can run this. This is going to execute and apply. And then I can go back to the select statement. And now I only see Jane. So these are the very basics of SQLAlchemy Core. I want to proceed by showing you how to model relationships. So let's say, for example, I want to have a second table, let's call it things. And this table that contains things is going to be related to the people table because a person can own a thing and a thing can be owned by a person and a person can own multiple things. So how is this modeled here using SQLAlchemy? How we can do that is, first of all, again, we provide things as a table name. We, of course, provide meta as the metadata object. And then we can say column ID again is going to be an integer, which is also, of course, the primary key. Then I can say I want to have I don't know, maybe we can say description of the thing is going to be a string, which is not nullable. Then I also want to have a value. So let's say it's going to have a certain price associated with it. Let's just give it an integer to keep it simple here. Or actually, let's go with a float, because that makes more sense and we can cover more data types. And then finally, this is now where it gets interesting. How do I connect these two tables with a foreign key? So I can say foreign key here as an import. And what I want to do is I want to create now an additional column. This column is going to be the owner. So let's call it owner. And the owner is going to be an integer because the integer is the same data type as the ID of a person. So that needs to match here. And I can now say that this will have a foreign key constraint where this is related to people.id. So this is how you would model that relationship. This is now a one-to-many relationship. One person can own many things. One thing can only be owned by one person. So that would be a one-to-n relationship. Now, if you want to have multiple people being able to own the same thing, you would have to do, in addition to what we already have here, you would have to do an association table where you have an additional table that has two foreign keys, one to the person, one to the thing, and then you would have both as a primary key. That would be a many-to-many relationship. The other way around, if you want to have multiple things being owned by, one thing being owned by multiple people, but not vice versa, you would just have to switch the foreign key constraint here. So you would have a column here, thing, because a person can only own a single thing. Doesn't make a lot of sense. And if you want to have a one-to-one relationship, we're going to cover that in the ORM. So I'm not going to cover that here. But what we can do now with things and people is we can do some more complex statements, let's say. But first of all, I want to add some data. So what we're going to do is we're going to say people. Let's call this insert people is equal to people.insert, and then dot values. What we can also do here is we can pass a list of people. So I can do it like this, and I can say dictionary here, name, and then Mike, age, and then 30. And then I can just copy that, do it a couple of times, and change the names. So let's say Bob, let's say Anna, let's say John, and let's say, I don't know, Clara. And then we have 30, 35, 38, 50, and then maybe 42. And then let's go down here and say insert things is going to be equal to people, things, insert values. And we're going to do this manually now without any fancy automatic recognition of which one is which one. We're going to just say that here the person ID, so the owner is going to be equal to, I think 1 is no longer present because we had Mike and we deleted him. So let's go with 2. Then the description is going to be equal to laptop. And then the value is going to be, I don't know, 200, or actually that's not a lot. So 800.50, for example. And let's copy that a couple of times here. We're going to have person 2 a couple of times, person 3, person 4, person 5. And let's say that here we're going to have the description mouse, keyboard. So he has a full set here. That's a $50.50 mouse. That's going to be a $100 keyboard, 150 or 100.50. Then here we're going to have a different, no, let's go with a book. Let's say the book is worth $30. Then we want to have here a bottle, I don't know, $10, 50. And then let's go with, I don't know, speakers, which are worth 80.50, for example. So these would be the things. And now what we do is we say connection, execute, insert people, connection, commit. And this is important, of course, because if we don't commit the changes made by the insert statement, we're not going to be able to access the IDs, because the ID is automatically assigned when the insert happens. So if I say Mike now is a new object, now we still have Jane, which has ID 2, so this would work, but Mike should now get the ID 3. But since we don't commit the change, or if we don't commit the change, we're not going to be able to access Mike. So if I say now connection execute insert things right away, and then I say connection.commit, we're going to see that this results in a problem. But first of all, we have another problem, which is we need to surround these here, of course, with quotation marks. But now this should work. If I run this, you can see that we get an error here, which says that the key owner 3 is not present in table people because we didn't commit Mike. So the reason we have the ID 2 is we had Mike, we had Jane, Mike had ID 1, Jane has ID 2, Mike was deleted, no longer present. So the next ID that is going to be created is 3. But since we didn't commit the changes, we don't have the changes made in the database yet. So we need to say connection commit, and that is going to create the people objects, and then we're going to have the ability to link to them here using their ID. So if I run this now, we get another problem. Okay, so my explanation was actually correct, but because of a couple of things that I ran here off screen, the ID has incremented a little bit more than just once or twice. So we now have 23, 24, and so on. This is also why you don't want to provide IDs manually. So now we have 23, 4, 5, 6, 7. Let's just go and change that. We had 23, 24, 25. Now if I run this, we should be able, I mean, I don't want to insert again, but now this should work. So seems to have worked. Let's go again, psql-u, and then Postgres DB name SA tutorial database select. Oh, sorry, I need to provide a password. Select everything from people, select everything from things, and now we have the owner linked here, as you can see. So Mike owns the book, and Bob owns the bottle, and Clara owns the speakers. Perfect. So that works without an issue. But again, this is not a good practice. What we usually want to do is we want to create a person, then you want to get the ID as a response. We're going to look at that when we go to ORM, and then you want to link that dynamically without having to manually specify the exact ID. But now what we can do with all this data in the database is we can perform joins. So we can join these two tables and make a select statement on the joined table. So what I can do here is I can say join underscore statement is equal to, and then people dot, and then I can decide what kind of join I want to have. Do I want to have an inner join? Do I want to have an outer join? Let's start with a basic inner join, which means we're going to combine the tables and only keep what's present or when both tables are relevant. So for example, some of these people don't own any things. These are not going to be included in the join table, because if Clara doesn't own anything, there's no reason to display her in an inner join when we join these two tables. So we only are interested in ownerships, and if Clara doesn't own anything, she's not going to be part of the table if we perform an inner join. So we're going to say people.join things, and then we have to provide the fields that are going to be used for that join. We're going to say people.c.id is going to be equal to things.c.owner. So where these two match, we're going to do a join, and then we can do another select statement here. We can say select statement is equal to people select, and then with underscore only columns. So we can choose the columns that we want to show. And in this case, we're going to go with people.c.name and with thing.c.description to see who owns what. And then we can say select underscore from, and we provide the join statement as the source here. So what we do is we say select the name of the person and the thing description, the description of the thing, from the join statement. And the join statement is basically join the tables people and things where the ID of a person matches the owner of a thing. And we can then go ahead and say result is going to be equal to connection execute the select statement, and then we can say for row in result.fetch all print row. And of course, we need to say things, not thing. And then we get Jane owns a laptop, a mouse, a keyboard, Mike owns a book, Bob owns a bottle, and Anna owns the speakers. So that is exactly what we wanted. This worked. And we can also do now a different type of join. So if I go ahead and say outer join, for example, that is going to give me all the people, even those that don't own anything. So even John and Clara that don't own anything, that would be a left join in this case, because we want all the people, even if they don't own things. Another thing that we can do now here, not necessarily because we have two tables, but what we can also do is we can aggregate, we can group. So for example, I can say here group underscore by statement is equal to things select. So I want to select the things, only specific columns here. And here now we're going to need an additional import. We're going to need the function import here, which is going to allow us to aggregate stuff, because when we group data, we also aggregate data. If I say group all the things by owners, I need to define what happens with the values, for example. So if I say I only allow for one row for owner 2, what does it mean? Do I sum up the value? Do I calculate the mean? That is the aggregation. So what I want to do here now is I want to say, I want to have the things.owner, and I also want to have func.sum. So I want to sum up all the values. So things.value. This is going to give me for every owner how much total value their items have or their things have. So I say select with only columns, and then I say group by, and I want to group by things.c.owner. And I think I need to do it here as well, sorry. Things.c.owner, things.c.value, and then we can do the same thing. Result is equal to connection, execute, group by statement, for row in result.fetch all, print row. Run this, and you can see that for person 2 we get 951 because everything summed up equals that, and all the others only own a single item, so they get a total of the value of that item. So this is how you can do that. You can also specify a condition here. So we can say something like, I'm interested in all of that, but only if the total sum is above, let's say, 50. So I can say having, and then the same expression, function sum things.c.value is greater than 50. And then again for row in result.fetch all, print row. That is going to give me 2 and 25. So now let us move on to the, in my opinion, more interesting part, which is the Object Relational Mapper. For this, we're going to open up a new Python file. This time we're going to call it just main.py. And here we're still going to do some basic imports from SQLAlchemy. We're going to say from SQLAlchemy, still import create engine, still import data types like integer and string and float, still import column. But then what we're going to do is we're going to say from SQLAlchemy.orm, import declarative base. That is going to be, okay, what kind of magic was this now? That is going to be the replacement for our metadata object or metadata class. We're also going to import session maker because now we're going to work with sessions, not with connections. And we're also going to import relationship, which is going to be important inside of the class to define the relationship between two different classes or two different tables. Because what the Object Relational Mapper is going to do now is it's going to map our Python classes to tables in the database. So we are no longer going to create the tables in terms of using the table object, but we're going to define classes. We're going to define columns in these classes. And then the Object Relational Mapper is going to allow us to treat individual rows as objects in Python and individual tables as classes in Python. And because of that, we also need the relationship function here, because it's going to allow us to say, when I have a person owning multiple things, I don't need to do a fancy join. I can just access a list of objects. I can have for each person a list of thing objects that I can work with in Python without doing any fancy SQL connections or joins. So what we're going to do first here is we're going to say, again, the engine is going to be equal to create engine create engine. Again, choose the database you're most familiar with or most comfortable with. I'm going to go again with Postgres plus psychopg2, and then I'm going to say Postgres at localhost port 5432 / what was it, SA tutorial database, and I still want to do echo equals true. And now instead of creating a metadata object, we're going to create a declarative base. This is going to be the base that we use to inherit from in our classes. So we say base is equal to declarative base. And in order to define a table now, what we do is we say class people, for example, or actually in this case, I would say class person, since the class is going to be in singular. I'm going to pass the base here as a base class. And now what I have to do is I have to define the table name. So __ table name _ is going to be equal to people. So person is what the class is going to be called in Python, and people is the name of the table in the database. So this one is usually plural. This one is usually singular. And now we do the same thing as before. I can say ID is equal to column. So ID is equal to column, which is an integer. The name is going to be automatically taken from the attribute name here. And I'm going to say primary key equals true. Then I can say name is equal to a column, which is a string. And nullable is going to be equal to false. Same as before. And then age is going to be a column. And it's just going to be an integer column. That's it. Now, what I also want to have is I want to have a class thing, which is also going to inherit from base. It's going to have the table name things. It's also going to have an ID. So column integer primary key equals true. It's going to have a description, which is column string nullable false. And it's going to have a value column integer column float actually, sorry. And then we need to establish the relationship between the thing and the person. And how do we do that? We do that again, first of all, with a column owner. So I'm going to say owner is equal to column integer, same as before. We need to import the foreign key constraint up here. So foreign key, and we're going to pass here people.id as a string. So same as before. But now what we can do is we can define relationships so that we can access, for a person object in Python, I can access the list of things that this person owns. And for the thing class, I can access the person that owns the thing. So I can do that by saying here, things is equal to relationship. Then I pass thing here as a string so that it knows the class. And then I say back _ populates person. So that is establishing the relationship that a person has things, and I can access the list of things by using the things attribute. And conversely here, I'm going to say person is equal to relationship, and I'm going to say person, and I can say back populates and then things. So that allows me to do the same thing. I can also just do it without that, I think, and then I can access the person. Let's give it a try. What we're going to do now to create the tables here is we're going to say base.metadata.create all, and then we're going to say engine. And then we're going to create a session. So first of all, we're going to say session with a capital S is going to be equal to session maker. That is like a session factory, essentially, which is going to be bound to the engine. And then the actual session in lowercase is going to be an instance of that. So now what I can do is I can say new person is equal to, and then person name is what's something that we didn't have yet. Maybe Sam. Age is 80. I can do it like this, and then I can say session.add new person, and then session.commit, for example. So if I run this now, we're going to see, oh, of course, no, this was a stupid mistake from my side. Of course, we need that because that backpopulates person, that backpopulates things. If we don't have the field, we cannot backpopulate it. So of course we need both. But when I run this now, you can see this is executed and that creates Sam in the database. We can also see that that is the case. If I go into my database and I type select everything from people, then we're going to see I have now an additional entry for Sam, and I still have my old entries here. And the cool thing now is if I want to add some things to Sam, I can do that and I don't have to provide the ID manually. What I can do is I can get the ID after I create the object in the database. So let's create another one actually. Let's say this is going to be Charlie. Charlie is going to be, I don't know, 70 years old. And now what we want to do is we want to assign to that person, to that new person, a new thing. So I'm going to say new thing is equal to thing, and we're going to say description. Description is equal to camera, and the value is going to be 500. Now, if I want to specify the owner of that thing, I would have to specify that the owner is equal to the ID of the person. So owner would be equal to new person.id. That is how you would do that. Now, the problem is before I commit that person, I don't have an ID. But sometimes also I don't want to commit before I have done everything. So I don't want to get an error here and have the person committed but not the thing. What I can do in this case with a session is I can say session.flush. This is going to temporarily add the person. It's going to give me the ID, but it's not going to write the changes permanently to the database. So what I can do is I can access that, and then in the end I can say session.commit. Of course, what I need to do before that is I need to say session add new thing. Otherwise, I'm not writing anything to the database. So let's run this again. And let's now look at the database. If I say select everything from things, I have a camera. The camera is owned by person 30. If I select everything from people, I can see person 30 is Charlie. Now, since I ran this twice now, I have Charlie twice in the database because this was executed twice. But you get the idea. I get the ID dynamically. I don't have to provide 30. I can just get the ID from the created object. And in Python, what I can do is I can now get a list of all the things that Charlie owns, and I can get also the owner of the thing by just accessing the attribute. So I can say, now this is of course always going to create now a new person or a new thing, but it doesn't matter for our purposes now. So new person, if I say dot things, I'm going to get the list of all things. And if I say new thing dot person, I'm going to get the person owning that thing as a Python object. So here you can see I get the thing instance and I get the person instance as a Python object. I can also say here person.name, for example, or here I could say a list comprehension t.description for t in things, if I had multiple of those. And then I would get camera as a list here and Charlie as the owner. So that is super convenient. I don't need to care about anything database related. I don't need to do any joins here. I don't need to do any manual database stuff at all. I just have to define the objects here as classes, and I can then use them, or the tables here as classes, and then I can use them as Python objects easily without caring about the database. Now, the syntax for querying, updating, and deleting is pretty similar to before. We just have to use different function names. So what we do in this case is we use session.query, and what we provide here as a parameter is what we're exactly interested in. So either the entire object, for example, person, or just individual fields like person name and person age. Depending on what I provide here, I'm going to get a different type of output. If I just say person, the resulting set, if I just do a select statement, is going to be a list of Python objects, a list of person objects. And if I provide person.name or person.age, I'm going to get a tuple, in this case with a string and an integer. So these are not going to be objects, not instances of the person class. These are just going to be the raw values, so the name and the age. We can take a look at that. If I say person name, person age, and then dot all, this is now the alternative to fetch all. This is going to return all the tuples to me. If I now say, if I store this as result, and if I now say print result, then what I'm going to get here is I'm going to get Jane 40, Mike 30, Bob 35, and so on as tuples. Whereas if I say just person, In this case, I'm going to get a list of Python objects which are not really readable, especially because we don't have a string function or a representation function here. So what we could do here is we could say p.name for p in result. That would give us the entire object, and in this case, I'm just printing the name of that entire object. So this is quite convenient because I can just work now with these classes and objects instead of working just with the raw values that I get from the database. Now, if I want to have some conditions, if I want to filter, I don't use the where function, I use the filter function. So in this case, I could say, give me all the people where the person age is above 50, for example. And in this case, this is going to only return Sam and 4 times Charlie, since we added him a couple of times to the database. If I set this to 40, for example, this is going to give me John, Clara, Sam, and the Charlies again. But this is the syntax for the querying and for the filtering in SQLAlchemy ORM. Now, we can also use that for deletion and updating. So let's do something that doesn't have dependencies. Let's go for the things. And let's say, or actually, maybe we're going to encounter some problems here because we do back population. Let's see. If I say, give me all the things where the value of the thing, so let's say thing dot value is below 50, for example. Let's see if we even have something like this. That would be t dot description for t in result. What's the problem here? Actually, I need the correct operator. Things is not defined. Thing is not defined, so... No, sorry. Things is not defined, so we need to go with thing. In this case, I get book and bottle. So what we can try to do here, let's see if this works, is we can say delete. And this should work. So in this case now it deleted the entries. So maybe if I go now and say just all, so maybe let me get this back here. If I say all, this should have deleted the objects. The only problem, of course, is I didn't apply this. So I have to say delete. Then I have to say session.commit. And then we can run this again as a query. So I can just say in the end all, and when I run this, you can see I get an empty list because the objects have been removed from the database. So we can use the same syntax here for querying. With all, I can use delete in the end if I want to delete it. I can also use update to do an update on a specific batch. So I can say, for example, let's go with filter where the person, so person name is equal to Charlie. What I want to do is I want to do an update. I want to say that the person should now be renamed according to a dictionary. The name now should be equal to Charles, for example. So if I run this, that of course is not going to give me anything here. But if I now say, give me all the person name values without a filter, just dot all. Oh, I need to remove the filter, and I need to also print the result. So print result. Now I should have 5 times Charles instead of Charlie. Also, we can easily do joins as before. So what we could do, for example, is we can say, give me the person name and give me the thing description. So 2 tables here, and I can just say then, this is joining the thing. So this would be query person name, thing description, joining the thing, all, and then I can print the results. And that would give me Jane laptop, Jane mouse, Jane keyboard, Anna speaker, Charles camera, and so on. And finally, grouping is also done quite easily. We just have to import func again for the aggregation function, and then we can do something like query thing.owner, and then function.sum thing.value. And in this case, we don't need to join, so we can just say group by and then thing.owner and then all. That's basically it. That is going to give us here the owner ID. And of course, we could do a join and get the owner name as based on the ID and so on. but we're going to keep it simple here. And then I can also, of course, do something like having, again, same as before. And I can say function something.value has to be above 50, for example. And that is going to give me only the IDs of the owners that fit this criteria. And in general, one thing that you want to do in the end, this is also going to commit, by the way, is you want to do session.close, also for the connection. You want to just close, and this is going to properly close the connection and also commit everything that's not committed up until this point. Now, another cool thing that we can do with SQLAlchemy is we can connect pandas to our database. So we can either take the data from the database and turn it into a data frame, or we can take a data frame and add it to the database. Both is very useful, and all we need to do for that is we need to import pandas. If you don't have it on your system, of course, you need to install it. Just pip or pip3 install pandas. And I still have my engine here, so all I have to do is I have to say data frame is equal to pd.read_SQL. And what I have to pass here is a statement, select everything from people, for example, and then I have to pass a connection. In this case, it's going to be the engine, and then I can just print the data frame in my command line. So you can see I get the database content here as a pandas data frame, and I can also do the opposite or the other way around. I can take a data frame and insert it into the database. So I can say, for example, new data is equal to pd data frame, and I can pass a dictionary here where I say name is going to be equal to, let's use, I don't know, what name don't we have already in the database? Let's use my name here, and let's use maybe Jack as well. And then let's go with age, and my age at the moment is 26, and Jack, let's say, is 90 years old. So that would be the data that I'm going to feed into the database, and then new data.toSQL, specify the people table, and the connection still has to be equal to engine. Now, if this already exists, if we have a problem here, we can say just append. So if the table already exists, we can just append to the table, and index equals false here. We are not interested in the index. I can just run this. Now, we didn't get any output for this, obviously, but I can comment this out now, run the code again, and now you can see I have these two new entries that are also loaded from the database. Now, last but not least, I would like to show you a practical use case, an example where I have used SQLAlchemy in the past in a project. This is an old version of a side project of mine called Brain Center, a management tool essentially for my YouTube channel, for sponsorships, for to-dos, and so on. And I used this in the past. I now have a more recent version that uses Django Ninja with the Django ORM. But in this Flask application, in this Flask version of the application, I used SQLAlchemy. I want to show you what this looks like. So basically here I have my app. I have the run.py file. So this is now Flask in general. I have the different blueprints. So I have YouTube, for example, and sponsorships and to-dos. And each of them has routes. So here, for example, I have the default route where I get the YouTube videos. You can see already I have YouTube video query filter. So here I get all the videos that are actual videos. Here I get all the videos that are ideas. And you can see I get filter, paginate. So I have different pages. I can also use query here to get, or actually this is, this is query or 404. But essentially what I have is I have the models behind the scenes. And you can see that I get DB model here. But what is DB model? What is DB? I imported from app. If I go now to, where's my app? If I go here to init, this is a database SQLAlchemy instance. Now, to be fair, here I'm using Flask SQLAlchemy, which is a wrapper around SQLAlchemy. So the syntax is not exactly the same. I'm using this SQLAlchemy object, which of course behind the scenes is SQLAlchemy. But all in all, it's the same idea. I still have my classes with table name. I still have my fields here with the columns, with the different data types, and also here with the representation dunder. And the routing or the querying is pretty much the same. I do query, order by, filter, all, and so on. You can see it's the same idea. So even though this is Flask SQLAlchemy, this is just another interface. The idea is you're using SQLAlchemy in Flask, and you also use it in Fast API, and you can also use it in Django. And it is what you use oftentimes if you choose to use it as an object relational mapper, so that you can work in Python with objects and classes, and in the database you have everything translated without any effort on your side behind the scenes. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. As always, if you enjoyed these longer crash course videos, let me also know in the comment section down below what additional content you would be interested in. And as always, you're supporting the channel if you subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in our next video, and bye.